We'll show how OpenResty X-Ray can automatically analyze programs without debug symbols inside OpenResty or Nginx application. It can rebuild debug symbols by analyzing the executable files through machine learning. Run the ps command to see the full command line for an OpenResty or Nginx process. We can see the path of the executable file for this process. This OpenResty is compiled from a source by the user herself. Use the file command to inspect this executable. Copy the file path. The file is stripped and lacks any debug symbols or symbol table. We cannot find the corresponding debug symbol installation packages for this program either. Then use the file command to check the Lua JIT dynamic linked library. Once again, the debug symbols for the Lua JIT file are also missing. Fortunately, OpenResty X-Ray has the superpower to generate debug symbols from stripped executable files. It makes it possible to do in-depth and full analysis via dynamic tracing. Open the OpenResty X-Ray web console in the web browser. Go to the guided analysis page. Here, you can see different types of problems that you can diagnose. Let's select these 4 types of problems. Click on Next. Select the OpenResty application. Select the worker process. OpenResty X-Ray can analyze multiple language levels at the same time. We'll keep both Lua and C selected. Let's start analyzing. OpenResty X-Ray will check if any executable file is missing debug symbols and then try to rebuild them automatically. The symbol rebuild task is now running. After the symbols have been successfully rebuilt, it starts executing all the relevant analyzers as usual. Let's stop analyzing. We can see it automatically created an analysis report. The first section of the report is for the CPU problem type. First, check out Lua's performance hotspots. Click to see more details. The hotcode path was automatically inferred from the C-LAN CPU flame graph. Click to enlarge the flame graph. We can see all the C function names, including inline functions. It even shows the C source file name and the source code line number. It looks like magic, doesn't it? Click to see more details. This is the #1 hottest Lua code path using the most CPU time. The close function is called by the generate function. This is a Lua function called generate. It is defined in the Lua source file lua/report.lua. The generate function was called by the generate monthly report defined in the lua/invoice.lua file. Hover the mouse over the green box for the generate function. We can see the full path for the Lua source file in the tooltip. The Lua source line number is 11. Click the icon to copy the source file path. Use the Vim editor to open the source file. And look at the Lua code in this file. You can use any editors you like. Go to line 11, as OpenResty X-Ray suggested. You can see the close function in the report. Even without the debug symbols, we can still get details about the hot Lua function and source line. The generate function is used to query the database and generate reports. Now, let's check out the memory report. On the Lua land, a good portion of the memory is taken up by dead Lua objects not yet released by the Lua JIT garbage collector. Click to enlarge it. Zoom in this data reference path. In this path, the table is the data structure of all Lua modules loaded by the current Lua application. Apparently, these loaded Lua modules also take up a lot of memory. OpenResty X-Ray can also monitor online processes automatically and generate analysis reports. Go to the Insights page. You can find the automatic reports on the Insights page for daily and weekly periods. For this reason, you don't have to use the guided analysis feature. Though guided analysis is useful for application development and demonstration purposes. OpenResty X-Ray is a non-invasive diagnostic system based on our own dynamic tracing technology. It can monitor and scan performance problems, behavioral issues, and security vulnerabilities in real time. If you like this video, please subscribe to our YouTube channel. Thank you.